Hello good day viewers. Let us do one more tutorial on how to apply L'Hopital's rule in evaluating limit problems. We have three problems in this tutorial and we are going to start with the first one, which is the limit as x approaches infinity of the function x to the power of 3 divided by e to the x. Alright, here is it. One thing you should observe, if you substitute infinity to the top and the bottom, you're going to obtain infinity over infinity, which is what? In an indeterminate form, which we don't want. Therefore, we are going to differentiate the top and the bottom separately. Therefore, we say that this is the same thing as the limit as x approaches infinity of what? D over dx of x to the third power divided by d over dx of e to the x. If you differentiate x cubed, you are going to obtain 3x squared. If you differentiate e to the x, you are still going to get e to the x. So this is the same thing as the limit as x approaches infinity of this function. And again, if you substitute infinity here, you're still going to get infinity over infinity. Therefore, we are going to redifferentiate the function again. So we say this is the same thing as the limit as x approaches infinity of d over dx of 3x squared divided by d on dx of e to the x. If you differentiate 3x squared, you are going to obtain 6x. So we have 6x. Divide by, if you differentiate e to the x, you're still going to get e to the x. Still, we are going to redifferentiate. This is the same thing as the limit as x approaches infinity. Again, we are going to differentiate it because if you substitute infinity, you're going to obtain infinity over infinity. So this is the same thing as the limit as x approaches infinity of d over dx of 6x divided by d over dx of e to the x. If you differentiate 6x, you're going to obtain 6. Differentiate e to the x, you're going to obtain e to the x. We're going to apply the limit as x approaches infinity. So from here, we are free to substitute our infinity, which is 6 divided by e to the infinity, which is going to make it a bottom heavy. And remember that if you have a fraction, the more the denominator becomes bigger, the more the fraction tends to become smaller, approaching 0. Therefore, the whole of this will approach 0 definitely. So this will be equal to 0, which implies that the whole of this limit, as it approaches infinity, it is going to tend to 0. Let us take the second problem. All right, here is the second problem. We have the limit as x approaches 0 of the function sine of 3x divided by sine of 7x. If you substitute 0, you're going to obtain sine 3 times 0, which is the same thing as what? Sine 0 divided by sine 0. And remember that sine 0 is equal to 0. So this will give us 0 divided by 0, which is what? Indeterminate. So therefore, we are going to differentiate the top and the bottom separately. This is the same thing as the limit as x approaches 0 of the function d over dx of sine 3x divided by d over dx of sine 7x. If you differentiate sine 3x, you're going to obtain cosine 3x, right? Then you have to multiply by the derivative of the inner function, which is 3x. That will give us 3. You divide by, you do the same thing. You have cosine of 7x multiplied by the derivative of the inner function, 7x. That will give us 7. So we are going to apply our limit to this new function. So we have the limit as x approaches 0 of this function. So now we are free to substitute x equal to 0. So this is the same thing as cosine of 3 times 0 is 0. So we have cosine of 0 multiplied by 3 divided by cosine of 7 times 0 is still 0 multiplied by 7. I remember that cosine of 0 is equal to 1, so this will give us 3 divided by 7, which implies that this limit will tend to what? 3 divided by 7. Let us take the last one. So here is the last problem. We have the limit as x approaches infinity of the function the natural log of x divided by x. If you substitute infinity, you're going to obtain infinity over infinity, which we don't want. Therefore, we are going to differentiate the top and the bottom separately. So this is the same thing as the limit as x approaches infinity of the function d over dx of natural log of x divided by d over dx of x. If you differentiate natural log of x, you're going to obtain 1 divided by x. So this is the same thing as 1 divided by x. If you differentiate x, you're going to obtain 1. So it's like dividing by 1, which will not change anything. So let us just leave it as 1 divided by x. So we are going to apply our limit from here. The limit as x approaches infinity of this function. So if you substitute infinity here, it is going to become bottom heavy, which will approach 0 directly. So this is equal to 0. Therefore, if you evaluate this limit, it will tend to 0, as simple as that. Thank you for watching. Do share to your learning colleagues, and don't forget to subscribe to my YouTube channel for more exciting videos. Bye-bye.